Hey, and welcome back to the lab. On YouTube, every subscriber is precious, and we feel you all need to be celebrated. So today, we're working on a project that was inspired by the guys over at Rumble Lab. We're going to do an interactive play button that celebrates every single subscriber. So lab code up. We're going to learn something today. Alright, so our friends over at Rumble Lab have taken note that YouTube has stopped sending out even the paper certificates for the 1,000, 10,000, and 10,000 level subscriber things for your channel. Now this was something you could print yourself, so it didn't cost them anything to do it. I don't know why they decided that, rewarding people wasn't a good idea, but people at Rumble Lab took it upon themselves to make a play button, 3D printed, that celebrates every single subscriber. For those of you who have been involved in YouTube, you know this as much as I do. It doesn't matter how big your channel is. Every subscriber is awesome, and every subscriber deserves to be celebrated. So we're building, or rather rebuilding and improving upon what Rumble Lab had already did. Now I'm going to go ahead and post a link to both Rumble Lab's channel and the video where he displays this in the description down below. Now, one of the things I noticed when watching his video is he didn't tell you how to build the button, which I don't know, I thought it'd be awesome to know how to build this. So I asked him if he would mind if I did the video showing how to build it, and because we do not replicate other people's work, we always expand upon it and make it our own in Mikeys Lab. We're going to add a few things and we're going to take one thing away. In Rumble Lab, they had audio for part of the button, which no. Right, I have a cat, I have small animals. As Rumble Lab found out, it terrifies his dog. So we're going to omit the audio, but we're going to add an OLED screen so that we can play animations and display the current number of subscribers that our channel has. Now, once this is all done, it's going to go about here. So you should be able to see it in every single one of our videos. So the first step was to go ahead and 3D print and 3D print the play button itself. Okay, now this was printed with white PLA, 0.1mm layer height. I did use support for this one, which means that there's a whole bunch of a mess to clean up on the inside, but I don't really care what the inside looks like. Okay, so down at the bench here, what we have, if I plug this back in, I don't have the LED strip currently in here, but this is essentially what we're doing. Right, and what the LED strip will do is it will play an animation sequence every time there's a new subscriber. I'm going to go ahead and turn off the studio light for a second, and hopefully you can see this now. And I'll bring that a little closer. We have the Mikeys Lab. We have a Mikeys Lab logo. And what it's doing right now is it's going out to the internet, using the YouTube algorithm to figure out how many subscribers I have, and then just playing that and playing an animation with it. At the filming of this video, apparently I have 760 subscribers. So that is the heart of what we're building. Right, I have a Node MCU already inside of the 3D printed case. What I've done here is I've taken an OLED screen. Actually, let me turn this light back on. Okay, I've taken an OLED screen, much like the one that was on the breadboard that I showed you before, this one right here. Right, and I soldered on an extension wire to it. Okay, so if we take a look at the actual pattern here, we can see that there's a 3.3 volt lead, which is what we'll need for the OLED screen. So I'm going to go ahead and just hook up to that 3.3 volt for the OLED VCC. There's a ground right beside it. So we're just going to go ahead and grab the ground. I've actually recorded this once before. It turned out that my cameras weren't recording. So you don't get the value of me absolutely complaining about how crappy my hot glue gun is. Maybe later. Okay, and then yellow is D1 and orange is D0. And nothing says happy like working for 20 minutes only to find out that your primary camera wasn't recording. That's always fun. Alright, so now we have the OLED display in place, and it's probably just going to wind up spinning around like this and being hot glued into the top part, so it sits there. Now I put a longer set of wires on here because this is going to be on the top part, and if I want to take this apart, I want to make sure that I have enough cable that I can still work inside of this, right, with this attached to the front of the panel, or the front of the play button. So the next thing we're going to do then is our LED strip. I already have a data wire hooked up to this. It was long enough, however the original power and ground were not long enough, so I gotta go ahead and attach another power and ground to this. So I'm just going to use my mic to try and hold this in place while I solder it. Okay. Just going to bring that a little closer, then maybe you can see on here what I'm doing. I just want to make sure, yeah, it's in shot. Alright, we got our solder. Clean the soldering iron. Those of you who've been here a little while know I'm a little nuts about cleaning my the soldering iron tip. But once again, as I've said many times, I am still, after 2 years, on the original tip of this Seiko. So now what I'm going to do is I'm going to grab some hookup wire. Actually, I had to go buy some hookup wire. And we'll go ahead and cut the length of that off. Black. And we'll go ahead and grab the red. You know, I thought this was going to be kind of crappy wire. It's not bad. Try to match the length here for the red. There we go. Okay. Now, as you see me do 1,000 times before, let's go ahead and tin this wire. I use this breadboard to hold it for me. I think once you do enough electronics, your fingers actually get kind of immune to heat. Alrighty. Using the soldering iron as always. Love these brass sponges, they're awesome. Alrighty then. So now, we attach these to here. Now I'm going to go ahead and use the shorter ends for this. And all we should have to do is just touch this basically. That is in there. Not quite as pretty as it normally is, but this is some really thick wire. There we go. That one wound up being a better connection. So then, what we want to do, we want to peel the backing off of this, exposing the adhesive strip on the inside here, like so. We want to bend this back like that. Wire is a little thicker than the wire I had intended to use originally, so I'm going to have to work with that. Okay. So I think the original play button that Rumble Lab had, when they sent me the STL files, when I loaded them in Cura, they were a tiny bit small, so I printed them at 2500%. Right, but I still think that I'm making this about half the size that they were. so the first connection I'm going to do for the LED strip is its data connection, which is going to go to D2 on the Node MCU. That. So now I kind of have to find a different way to do this, I think. I'll look for another 5-volt pin here. The first one then I'm going to do is the ground. So I'm going to trim. Ground wire. Now we need to find 5-volt source for this system, but I'm going to go ahead and just top off a V in for power for the LEDs. And I'll probably add another wire to this connection. Go. Alright, so let's just plug this Node MCU in and see if we get any smoke. No smoke and the LED is on. Okay. We of course haven't uploaded any firmware to this thing yet, so it doesn't do anything like this one does. But we'll get to that in a moment. Alright. So the next step that I want to do is I want to remove the actual inside of the play button. Now, if I was smart, I would have modified the STL before I printed it in order to give me room for this, but I didn't. So what we're going to do here is we are going to go ahead and we are going to I guess we just use a Dremel to cut that out. I think that'll work just fine. I made pretty short work of that. And lots of dust. Alright, so now I'm just going to take some regular sandpaper. Make sure my camera's still recording. Try to just knock down some of the high points here. Okay. Then what we're going to do, and this is one of the modifications I'm making over top of Rumble Lab's original one. I'm going to take some of this reflective when dark behind material here. I'm going to plug my crappy hot glue gun back in and wait 10 minutes for this to heat up. I can't believe how long that thing takes to heat up. Okay, so now I'm just going to run a quick bead of glue all the way around. Wow, my hands are shaky today. Around the opening of the play symbol. We're gonna stick this down, trying to keep it as tight as possible. And what we have is this shiny reflective play button that if we put light behind it, shines right through. So I'm sure you guys can figure out what the next step is. So we're going to take this display, remembering to peel off the protective layer. We're going to make sure that it is the right way around. And try to center it as much as possible. I want to be careful of the LVDS cable, a small ribbon cable. I don't know how sensitive they are to heat, but get all the crap away from there. Alright. So, once that dries, all that's really going to be left is the power supply for this unit, which, to be honest, I'm not sure how I'm doing yet. Let's find a wall wart. So we'll chop the end off of this guy, like so. Strip it back. Okay, so where you're going to come in, I'm actually going to come in his original design. He includes a slot in here for the cable. I don't know if it's going to be big enough for my cable. If I do some finagling, yes it will. Alrighty then. We will go ahead and strip that. Strip that. And turn my soldering iron back on, because for some reason I turned it off. Heiko, it gets hot fast, but you get spoiled by how fast it gets hot, so sit here and kind of, are you ready yet? 2 seconds after you hit the power button. And in reality, I'm used to, with cheaper irons, waiting like 15 minutes. Let's plug this in. One that's actually still in contact. Yes, I do have a blue light. Okay, I'm gonna need my crappy glue gun. So we'll plug that in so that it's ready in like 20 minutes. Alright, it's enough to plug it in. Do I have power? I have power. We don't. Ah, yes, it's the test sketch where it just flashes the status light. Alright, my power's not flopping up and down. Fill this socket right here with hot glue, just to provide some strain relief for the plug. Ladies and gentlemen, do you believe this completes the physical build? Alright, so as you saw in the last part, we completed the physical build of the play button. We have it together. We have everything soldered, one power cable coming out of it. As you can see, the actual play icon in the button is very shiny when there's nothing behind it. So let's go ahead and plug the device in. As you can see, it boots up, and red means it's looking for Wi-Fi, green means that it's found its Wi-Fi and is connected, has an IP address, and at this point it's going out to YouTube and asking for statistics. Once it's done that initialization, it will do the color wheel around, which is the same celebration it does whenever we get a new subscriber, which is this one right here. I promise I'll do something more interesting later. Once this color wheel is done, you're going to see this OLED screen here turn off while it goes and gets the full statistics from the internet. Once it has them, it's going to display them in that OLED screen. Now, I have no way of knowing when it's done that because I'm looking at a camera. And it looks like it has now. So as you can see, there's 763 subscribers, which means we've gotten a few more since the last time we took a look at this project. So it is assembled, it is working. I have burned its firmware to it, so why don't we go ahead and take a look at the firmware. Now, as always in Mikeys Lab, I have put the firmware up on GitHub. For those of you who want to jump ahead, link is in the description down below. But let's take a peek at the actual code that I wrote. We start off with a few includes. Most of these are just libraries that you don't really have to worry about now. We're using the NeoPixel library, we're using the SSD1306 library, and we're using the libraries for the ESP8266 and a secured Wi-Fi client library, which will help us to deal with the HTTPS request later on. We have a couple of defines that come next. Now these defines deal specifically with this OLED screen. The first one we set is the OLED reset pin, and we just set it to LED built in, which I'm pretty sure isn't actually connected to anything, but if we don't define a reset pin, the screen doesn't work. Next define we do is the I2C address for that screen itself, which is 0x3C, which is the default address for these screens. The next three lines are defines for the LED strips around the outside of the device. The first one that we set is we want that the brightness of the LED strip to be 50%. For two reasons. One, these LED strips are very bright, right? So running them at 100 is almost blinding. But also running them at 50% is going to extend their life and going to cause them to generate significantly less heat. The next value we set is the number of pixels. Now what that is the number of LEDs that are actually around the outside. If you're using a more dense strip or a less dense strip, it might be different than the value that I have, and you need to make sure that those are right. So for ours, it's 24 pixels around the outside of the thing. The next value that we set is the strip pin, which is the data pin on the Node MCU that talks to the LED strip, which for us is D3. So we power up the Adafruit OLED library, passing it the OLED reset pin that we defined up above as just LED built in, which again I'm pretty sure isn't actually connected to anything, but if I don't pass it the pin, it doesn't work. The next thing we set up is the NeoPixel strip, right? We set it with the number of pixels that we have, which in our case is 24. The strip pin being D3, and the color mode. Now this is very important. If you're using one of these strips and you can't seem to get a pure white, like there's more colors behind it, chances are this is set to Neo GRB W. It will still sort of work. You don't want to know how long it took me to figure that out. So the next part of the source code is kind of, I'll give it a black box, and maybe I should have used a comment here, but we all know I hate comments. So what this is this is the hex code to display that Mikeys Lab image, right? Just per pixel basis values to display that Mikeys Lab image. Now I used a program that took in a BMP and spit out the hex values for each pixel so that I could assign it to an array and it can be used to show the logo. Okay, so after we're done with that logo, that big array of pixels, hex values per pixel for displaying the Mikeys Lab written text that we see it showing it right now, which I think is pretty neat. The next thing we do is we define a global for the googleapis.com host. Now that's the server that we're going to connect to and ask for the data of our subscribers back. We're going to connect at port 443, which is our default HTTPS port. Now, fingerprint is an interesting beast. Some machines call it a thumbprint. What an SSL certificate is it's somebody on the internet telling you that the server that you're communicating with is the server you think it is. Now, usually this is a trusted facility that says, yes, I know that this is Google. I've dealt with them. It's definitely Google's server, right? You can trust them. But what comes back then is the certificate ID. Now, dealing with certificates on a microcontroller or something as weak as an ESP8266 is going to be a pain. There's just not enough processing power to do it properly. So we take the fingerprint and we compare it and we vouch the server that way. Now, this is not a big deal for what we're doing here. We're literally only asking for data. We're not giving them any. And SSL starts to become more important when you start giving them your data. So the next couple of lines are for setting up the Wi-Fi. Obviously, you want to replace your SSID with your SSID and your password with your password. But this is the information that this play button is going to use to connect to your Wi-Fi. Below that, we have another global called current subs, or cur subs, which is the current number of subscribers we have. We set it to 0 now before we update from the actual display, or we set it to 0 before we updated from the API. That's why when the device is booting, it plays that circular animation for us. We tell it that the next update in milliseconds, which is a global, is 0. Now that tells us that we need to update the information from the API now. We have an update delay in milliseconds of 2000, which means we're going to try to update the information from the Google API every 2 seconds. Now, we're probably not going to be able to accomplish this because of other stuff that's running taking longer than 2 seconds to get back to the run. But basically, we're going as fast as we can. So, on any Arduino sketch, the first thing that runs is the setup function. We begin our serial at 115200. Again, this is mostly for debugging. We're not using it too much with this project. First function that we call is setup display. So if we go to the definition of setup display, you can say we call display.begin. We tell it to generate the high voltage that it needs from the standard VCC line, and we pass it the I2C address of the display. This allows the library to handle it, and we then go to show logo. So if we go to the definition of show logo, we tell it to clear the display and display the blank display. Right? Then we draw the bitmap, which is referenced to that logo array, and we tell that to display. Now what this is going to do is it's going to display that Mikeys Lab logo until something tells it to display something different. So if we go back then, back up to the setup, the next one that we call into is setup strip. So let's go to the definition of setup strip, which is basically strip.begin, and then we set the brightness to 50%, and we tell it we want a white strip. Now this is only going to be there very momentarily, because as soon as we get up to setup Wi-Fi, we're going to change the color to what it normally is. And in white strip, if we take a look, all we do is we enter a for loop, we go through each individual pixel, we tell that pixel to be white, and we say show it. So if we go back then to the setup function, the last one in the setup function is setup Wi-Fi. Go to definition, and as you might imagine, you see us printing out some stuff to the serial port. We set the Wi-Fi mode to be a Wi-Fi client. We tell it to begin with the SSID and the password that we want to connect to. And then when we're waiting for it to connect, we sit here and every half a second, we go through and we print a dot onto the serial connection, and we ensure that the color strip is still red. This is what causes that red at the beginning before we have an internet connection. Once we are fully connected, we do a color wipe of green, which gives us that green that shows us that we are connected to the wireless network. And we use the serial to spit out the IP address of the device. Again, that was more for troubleshooting than anything else. So if we go back then, the next function that always runs on an Arduino program is loop. So we take milliseconds, or millis if you're unfamiliar, will give you the milliseconds since the device booted. Okay? So we're saying if the milliseconds is greater than the next update milliseconds. So what we're saying is if the device has been up longer than when we were supposed to update, we need to update now. So we set the next update milliseconds to be the current milliseconds plus the delay, which as you remember from the up above is set to 2 seconds. So we want to run this again 2 seconds from now, or the earliest convenience after that. First thing we do is we get the YouTube statistics. I don't need to go to definition for that, it's right down here. We set up our Wi-Fi secure client. We say that we're going to allow self-signed certificates. Now if you don't know what those are, a quick Google search will help you with that. We go ahead and we connect to the site itself over the HTTPS port, and then the site's going to pass us back the certificate, which is stored inside the client object. So then we look to see if the client matches the fingerprint. Now the fingerprint again is that that checksum value for the certificate. If it does, we continue. If it doesn't, we say the certificates don't match, and we're not going to be able to pull data from the site. Now the next part is one that you're going to need to pay attention to. Yes, I know string, but the Wi-Fi library only uses string, or the web client library only uses strings. I can't pass it a car array. But as you can see later on, I bail on the strings as soon as possible. So we're going to the statistics part of the information. The ID, you obviously want to replace this with your channel's ID, and this with your channel's API key. Those values being passed to the server are going to request the information from it in a JSON format. So we go ahead and we build the requesting URL here. And as you can see, we're nice enough to tell YouTube that we're a play button that's requesting the information. I would love to see what happens when somebody actually looks at the statistics from this and sees play button. User agent is usually Mozilla for Firefox, Chrome, or Edge, or Internet Explorer, or whatever browser you're using, Safari for the Mac people. Alright, so then we go ahead and while we're connected, we keep reading the string data out of the client until we hit carriage return. Carriage return in this particular instance will always indicate an end of the response. So that means we've received the headers and we break out. We create a character array called buffer that's 750 characters big to hold this. We take the entire read of what the client returned, and we spit it out to that character array. Then we pass it to a function called parse subs. Right, this is a short but powerful function. So we take in the car array JSON, which it was formerly known as buffer, right? And then we say JSON equals stir JSON subscriber count here. What this is going to do is it's going to delete everything ahead of this set of text. So anything that was before that we don't care about, we just went bye-bye. Okay? So we define an integer at this point called new subs, which is the new number of subscribers that we have after this. We use A2I, which if you've watched my other videos, you know will take text and convert it to an integer, but it will also stop at the first non-numeric character it comes in contact with. This is handy. So we're gonna pass it the buffer from JSON starting 20 characters in. And if you do a quick count here, you'll find that after that space, after the colon, there is precisely 20 characters. So then we say, the new subs that we just got, is that higher than the number of subs we knew we already had? If it does, we call new subscriber, because it's time to celebrate. New subscriber basically prints the serial line, new subscriber, clears the display, sets the current subs to the new number of subs, does that RGB color wheel animation 5 times, turns the strip back to white, clears the OLED display, goes to a function called pop subs. Now what that does, if we go to the actual function here, is it enters through a for loop, displaying the number of subscribers in small text, growing to bigger text to the point that it's the size of the text that it animates, back and forth. I'm just trying to delay here so that I can show you what I'm talking about. So you can see the 763 going back and forth there. That's the size that it will end at. And then it clears the display and returns. So then we wind up all the way back up now into the loop function, where we check to see if it's time to run again, and if it isn't, we wait. If it is, we immediately proceed through again. So this isn't complicated source code. It really isn't. It's a couple hundred lines of code, nothing too overly complex about it. For those of you who noticed, I am using Visual Studio with Arduino as opposed to the Arduino IDE. It's a plugin called Visual Micro. If you want me to do a review on it or talk to you about it, by all means, leave a comment down below and I will. But that wraps it up for our interactive play button and our subscriber celebrating play button that was shown to us by Rumble Lab. They did a wonderful job on this. I think we've expanded it and hopefully done them justice. So I want to go ahead and thank you for joining me in the lab. I hope you learned something today. We will talk again soon, and I will see you next time.